Thank you. Thank you for having me. I am really honored to be in this distinguished community here today, first time in Goethe University, so thank you so much. Yes, I represent Macolab, which is a European company headquartered in Poland with offices in, of course, Poland, Paris and London, and Chemical Semantics, which is our joint venture in the US for semantic web, and recently we entered into blockchain research in this company as well. The purpose of my talk today is to show you how blockchain can be used for digital identifiers, specific blockchain solutions, specific software, and specific evolutionary step in the blockchain history for that purpose. So my plan for today is to tell you a little bit about the challenges for digital identifiers, then why blockchain can solve them, can address these challenges, and what are existing examples that were fully commercialized or maybe not sometimes commercialized but very popular for identification on the web, and our own case studies. So the first one is DOI, Digital Object Identifier, and LEI, and then I will go into our fully functional proof of concept which we created, where we built LEI resolution mechanism on top of blockchain, and what are the lessons learned. Okay, so first and foremost, what digital identifiers, what kind of challenges they have? First and foremost, they must provide uniqueness. They must answer who is who, without any doubt, referring to what Stefan just explained in his talk. And then they must be accessible free of charge and form broad public good. And I borrowed these slogans from the Spring conference here, in this room, I believe, because that's what actually was important for identity, as was discovered and presented there. Then, of course, extremely important thing for identifiers is decentralization of their generation. Unless some specific examples, some specific identifiers, all of important identifiers are actually generated in decentralized mode, and they must be like that. And they must preserve bidirectional non-repudiation, so nobody can really repudiate that this identifier belongs to this object and vice versa. Authenticity, and of course must be resilient to system failures. Some existing examples that we know very well, so LEI, of course. Then recently Fiji, which was converted from Bloomberg Symbology, which is the identifier for financial instruments, extremely interesting thing for finance. All sorts of CRNs for different jurisdictions, countries, company registration numbers, European VAT numbers, electronic product codes like GS1, AN codes, DOI that I will talk a little bit later, and of course VIN, vehicle identification numbers, which we know very well, and all of them are identities. Finally, recently we have GPII, which is Global Patient Identifier. Actually, GPI is from the GPI Inc. that tries to create this global patient identifier for health services. Where we are, okay. Now, why we turn to blockchain in the first place, without even thinking about our own role, our own POC or whatever? Blockchain certainly is something that delivers non-repudiation of transactions, identities, things that are in it. The data are immutable. We have full decentralization of processing. There is no question that it lowers the cost of transactions in the distributed environment. It's transparent to internal and external stakeholders, regulators, as we witnessed today. So, and it's resilient to any failure. So basically, that's a fundamental reason. It also has efficient replication mechanism, allows for far-reaching democratization of identifiers, and in some other cases, it allows to restrict generation of identifier to some authorized agents. So it's really a good technology, and for us, like a trigger was the recommendation by a small consulting, maybe not very small company, Ledra Capital, in their mega master blockchain list already in 2014, where they predicted that blockchain will be used for all sorts of public records, for identity of these public records, including land titles in the real estate and all these strange identities that we are using today on the world. Why it doesn't sometimes go? Okay. Existing examples that for identification on the web that exist and are working. perhaps the most famous is Blockstack. That was the first implementation of decentralized DNS system. They initially used Namecoin, which is actually already the cryptocurrency for identification in some sense. Later, they switched to Bitcoin, so it's like a structure over Bitcoin to provide the identification for the alternative DNS system. And recently, we have a plethora of companies that are startups that are in this space, like ShoeCard, that recently proposed interesting case for identification of passengers for global travel context, Hyper, Blockout, CryptID, and probably the number is growing. But I think that Blockstack and Namecoin are the most important identification services that really work. Blockchain evolves. And we think that the time is now with blockchain 2.0, mostly represented by Ethereum and some other initiatives of that kind, to create some structure for identities. This is this blockchain 2.0, as it is named by Melanie Swan in her famous book, Blockchain. And I think that I have a trouble to sometimes switch that. Okay. What is our idea? The thing that we really invented on top of this research. The idea is that we want to use, well, first and foremost, the concept. The ID or key and the data in our approach is atomic. It means that we treat the identifier and the first associated data as atomic object without any changes inside, any manipulation inside this object. That's the first assumption. Then the single atomic record can be considered as a state for single smart contract. So coming to, Stefan, to your talk, we have a transaction for creation or modification of a record, but the state is representing the state of a smart contract. So, and as you know, people who program a little bit Ethereum, you can call by something called dry run the state of the contract without actually making any changes on the blockchain. That allows us for pretty fast access to all states which are actually in this blockchain. Each such contract then offers a method for accessing the representation, and the dynamic data structure where holds revisions. Revisions are important, and here is the point about transaction and the state. Actually, we believe that there are multiple states in the blockchain representing a state of a given object or entity in time, from the beginning of a transaction, or from the transaction that created that to the moment when it was revised. So that's a little bit different concept of state and transaction altogether. Of course, we call all this structure entity contract because it's like a bigger structure representing not only single ID, but also its evolutions. Together with entity contracts, we can also create something which is called master contract that keep tracks of all these things. Basically, this is used for situations when we have an ID for a bank that changes in time. I must speed up, certainly. Okay. For the architecture of a blockchain, what we propose is something called blockchain, consortium blockchain. It was introduced by creator of Ethereum, Vitalik Buterin, in some extremely nice article on his blog where he contemplates how we can create semi-decentralized, partially decentralized blockchains. Is very interesting. So basically it means that the blockchain in our concept is run by organizations that are responsible for given identifier. Very quickly, DOI is the work that we are doing in states. DOI, Digital Object Identifier, is perhaps very well known to you guys because it's used for our publications everywhere. And recently, through DataCite, it became extremely important for identification of data sets in the global space. And our idea is essentially to replace the aging handle system, which, by the way, is extremely well designed, but it's aging, it's old technology, by blockchain on, or completely or on the level of the database. And that's actually the project that at this phase is only conceptually evolved, and we are working with National Science Foundation for funding for this project for next year. Hopefully it will happen. Now I will quickly go to LEI, the most important part of my speech. I don't need to define LEI in this room today, so let me skip this. I only wanted to stay for a second for the extremely important part of these identifiers. This is a resolution mechanism. Here is the point where we will see later how we must extend the technology of blockchain to some other elements because of this resolution. Glyph, that Stefan represents, offers resolution that if you take LEI and form such URI, you can actually get a humanoid, so to speak, display of the LEI record. There is another, all sorts of private LEI resolver, including one that Macolab created. It's under lei.info, which delivers humanoid resolution, but also linked data semantic web resolution with all sorts of data formats. And that's quite important. Now, our proof of concept that we built models a small consortium blockchain, only 3 nodes, so that was very minimalistic set. We used Ethereum software, not Ethereum the cloud, Ethereum software in our own our own data center. Ethereum clients form a private networks, and each client synchronizes its blockchain with others, and that models 3 LOUs, legal operating units of LEI system. And I will certainly skip technical details, only to tell you that to actually provide this resolution mechanism, it happened that we cannot stay only on blockchain software as delivered by Ethereum open source platform. We had to use SOAR for indexing. We had to invent special security mechanism, how to make sure that nothing happens also on the SOAR level, on the indexing level, and REST API and a lot of technologies over blockchain to actually provide this fundamental thing, resolution. Why? Because if you don't provide these, then the blockchain is extremely hard to be, it's almost impossible to use. It requires some technical skills to find LEI. That is nonsense, okay? And that's for every identifier. Okay, it had a very nice web interface. This web interface allowed us to, manipulate, see how the transitions are going, and explore JSON LD structures that we have, and basically work with these. Lessons learned, last slide, almost last slide, okay? I will skip on that, stop on that. I did not go to conclusion. So, first lesson. Ethereum is a very good platform for building digital identifiers, blockchain-based system. We proved that it really works. Just a few numbers that are not here. If we even take the whole set of existing LEIs, 400,000, we are going into something 1 gigabyte of blockchain. With all potential revisions, we estimate that today we would not use more than 2 gigabytes. So that's extremely small blockchain for everything we have right now in LEI. When it grows, of course, to the full, it will be bigger, but that's very good scalability from the size perspective. However, blockchain software is not enough to build a fully functional identification system. That's this lesson that is learned. We need indexing and caching for time perspective and for searches, for things that, as I said, Stefan clearly elaborated before. And of course, when you do that, you need to provide index and cache security, and that's extremely important. Now, proof of work, very important thing in this case. So we worked how to really make proof of work appropriate for a given phase of our work. Like when you create a first blockchain with all 300,000, you need low proof of work, low difficulty proof of work, because you need to do that in a reasonable time. Later, you can rise these, and of course, Ethereum, as you know, provides that. And the final, and one of the most important findings, we need semantic layer on top of these smart contracts and the data representing blockchains for 2 reasons. One, again, we need to confront this data with other blockchains. That's something extremely important. And also, without that, we will be creating standards that will not be interoperable. So that's like final conclusion, which I can't have time to evolve, but that was one of our findings that we do. This slide only. What we do now, adding semantic layer, improving security, and adding linked data resolution mechanisms, our next steps. Thank you so much.
Thank you very much. Great. Stay up here. Thank you, Mirek. Questions? Who wants to put up the first question? Any questions? Anywhere? Question? No question?
Okay.
Okay, wonderful. Thank you. Wonderful presentation.
Thank you for that. Thank you.